Hi my dear students, welcome back to our amazing YouTube channel of Brilliant Qatar. This is the 8th video lecture in our JEE Mantra series, and in this video we will be revising the chapters Quadratic Equations, Complex Numbers and Statistics. First we'll start with Quadratic Equations. So quadratic equation or a quadratic polynomial, a polynomial of degree 2 is known as a quadratic polynomial, and any equation which is of the form f of x is equals to 0 and f of x is a quadratic polynomial is said to be a quadratic equation. So general form of quadratic equation will always be of the form ax square plus bx plus c is equals to 0, where the value of a shouldn't be equals to 0. That's it. So if a equals to 0, then the equation becomes a linear equation. Next, roots and solution of any equation. In general, majority of the students were not having good clarity with respect to roots and solutions. Let me tell you friends, coming to roots, any equation of degree n, will be having n roots for sure. That's it. Any equation of degree n, any nth degree equation will be having n roots. Okay. Now of these roots, only the real and distinct roots are called as solutions. Only the real and distinct roots are called as solution. Now I'll give you an example friends. See, quadratic equation will go with quadratic equation. First one, x square plus 2x plus 1 is equals to 0. One quadratic equation. X square plus x plus 1 is equals to 0. Another quadratic equation. X square plus 3x plus 2 is equals to 0. Another quadratic equation. Now if we look at these three equations friends, let's see. In all the three cases, these three are quadratic equations. So degree 2 for sure will be having two roots. Here also two roots. Clear? Now, what are the two roots? Let's say x square plus 2x plus 1 is equals to 0. We can write it as x plus 1 whole square is equals to 0. X is equals to minus 1 and minus 1. So, two roots but repeated roots. Whereas in this case, if you observe d is equals to b square minus 4ac, 1 minus 4 which is less than 0. So, we will be getting two imaginary roots. No real roots in this. Two imaginary roots. Whereas in this case, we can factorize this as x plus 1 into x plus 2 is equals to 0. So, x is equals to minus 1 and x is equals to minus 2. In this case, again two roots, but these two roots are real and distinct. Here repeated roots, no real roots, real and distinct. So, in all these three cases, we say that these quadratic equations are having two roots. So, we can conclude that friends, any equation of degree n will be having n roots. Now coming to solution, what do we mean by solution? Solution means the number of distinct real roots of an equation. The number of distinct real roots of an equation is called as a solution. Now how many number of solutions in this case? Though it has two roots and those two are real roots, but these two are repeated. So how many distinct real roots we have? Only one. So that means x is equals to minus 1 is the only solution. So one solution we have in this case. In this case, no real roots, so no solution. Number of solutions, if you say 0 in this case. Whereas in this case, we have two roots and these two roots are real and distinct. So we say two solutions. So any equation of degree n will be having n roots and the number of distinct real roots, we call it as solution. Next, identity. In simple words friends, identity. In general, just now I said f of x is equals to n. If f of x has degree n, if degree of f of x is equals to some m, then we said it has n roots. Clear? It will be having for sure n roots. But if there is a statement that if f of x is equals to 0 has more than n roots, then that statement is called as an identity. A mathematical statement, an equation of degree n will be having n roots for sure. If it has more than n roots, then such a statement, such equation is called as an identity. That's it. In simple words, identity means any equation of degree n will be have if it has more than n roots, then such equation is called as identity. Now, how do we use this identity in case of our quadratic equation? A quadratic equations ax square plus bx plus c is equals to 0. Friends, if they say it is an identity, what do you mean by identity? Now this quadratic equation, for sure it should have two roots. But if there is a statement that a quadratic equation has some 5 roots, has some 10 roots, in all those cases our quadratic equation is called as an identity. So to make it identity, what we do, we equate these 3 coefficients, a equals to b equals to c is equals to 0. Then only, friends, only in this case, see, if we write 0 into x square plus 0 into x plus 0 is equals to 0, for any number of values of x, this is going to be true. Clear? So a quadratic equation ax square plus bx plus c is equals to 0 has more than 2 roots, then such equation is called as an identity. Whenever we come across this identity, what we do, we equate the coefficients of x square and x and constant a equals to b equals to c to 0. Clear? Relation between roots and coefficients of a quadratic equation. We all know, friends, ax square plus bx plus c is equals to 0. We found the roots by using the quadratic formula minus b plus or minus root b square minus 4ac by 2a. If alpha comma beta are any two roots, then sum of the roots is equals to minus b by a. Product of the roots is equals to c by a. Quadratic equation whose roots are alpha and beta will be x square minus x into alpha plus alpha into beta is equals to 0. Next, nature of roots. Nature of roots. We all know, friends, if the discriminant is greater than 0, then roots are real and distinct. If discriminant is equals to 0, roots are real equal roots. We say repeated roots. Repeated roots are equal roots. If discriminant is less than 0, then roots are imaginary. Roots are imaginary. Now, in this case we call them as roots are real and equal, or we say repeated roots, okay, or equal roots. One most important formula I would like to give you from quadratic equations, which we see from recent years, from past 2019, 20, 21, 22, 23. Every year we see one question from quadratic equations, and mostly it is from this formula called Newton's formula, friends. Newton's formula. Newton's formula, which is very, 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 very important. Now, what is Newton's formula? If they give you a quadratic equation, ax square, let's say ax square plus bx plus c is equals to 0. Okay. Now, whenever you will come across some statements like let's say pn or an, they give you pn is equals to something like pn is equals to alpha power n plus beta power n, or they can give you pn is equals to alpha power n minus beta power n, alpha power n minus beta power n. In all those cases, friends, we use Newton's formula for sure. Whenever you come across pn or some statement an is equals to alpha power n plus beta power n or alpha power n minus beta power n, that means they have given a hint to us to use Newton's formula. Now, what is this Newton's formula? Just very simple. If pn denotes that statement, friends, then a times pn plus b times pn minus 1 plus c times pn minus 2 is always equals to 0. Descending order of consecutive p suffixes, pn. If you are starting with n minus 1, n minus 2. If we start with n plus 2, let's say a times of p n plus 2, b times of p n plus 1 plus c times of p n is equals to 0. This denotes Newton's formula, friends. Newton's formula, which is very important, and we write it as A times Pn plus 2 plus B times Pn plus 1. So C times Pn is equals to 0. Always in descending order with the coefficients of A, B, C. This is what we say Newton's formula. Now just give a try for this particular problem by using this Newton's formula. Okay. Let's try this. Alpha and beta are two real numbers. Alpha plus beta is equals to 1. Alpha into beta is equals to minus 1. Most important thing is, friends, to get Newton's formula, first we should know the quadratic equation. To apply Newton's formula, we have to know quadratic equation. But instead of quadratic equation, here they have given sum of the roots and product of the roots. If they give you sum and product, can't we get the equation? Yes, we know x square minus x into alpha plus beta, that is minus x plus alpha beta minus 1 is equals to 0. So here A value is 1, B value is minus 1, C is also minus 1. Now what they said, Pn minus 1, Pn plus. So friends, we start with A Pn plus 1 plus B times of Pn plus C times of Pn minus 1 is equals to 0. Okay. Now what is A? A is the coefficient of x square, 1. 1 into Pn plus 1, 29. Minus B is minus 1, B into Pn, we should find Pn, plus C is again minus 1 into Pn minus 1 is 11 is equals to 0. So Pn is equals to 29 minus 11, which is nothing but 18, friends. Now they are asking Pn square. Clear how easy it is? 18 square is the answer. So that's how we use Newton's formula in quadratic equations, which is very important. Whenever we come across these statements, alpha power n plus beta power n or alpha power n minus beta power n, we should use Newton's formula, mostly majority of the cases. Next, common roots concept. Coming to common roots concept, friends. If two quadratic equations, let's say a1x square plus b1x plus c1 is equals to 0, a2x square plus b2x plus c2 is equals to 0 has one common root. One common root means, let's say alpha be the common root. Let alpha be the common root for both the equations. Let alpha be the common root of both the equations. Then alpha should satisfy this equation, whereas this equation also, correct? So if you put alpha in place of x in this case, a1 alpha square plus b1 alpha plus c1 is equals to 0, and a2 alpha square plus b2 alpha plus c2 is equals to 0. Friends, simple thing. Now by using these two equations, just solve alpha. You can solve alpha either by using some elimination method or some substitution method. You can eliminate either alpha square or alpha. From there you will be getting the value of alpha. By using this equation, no need of remembering any formula. Just by using this equation, we can get everything. We can get the required in that particular case. Okay. Now, if both the roots are common, let's say a1x square plus b1x plus c1 is equals to 0, and a2x square plus b2x plus c2 is equals to 0 has both roots common. In this case, what we do, if these two equations have both the roots common, then it happens only in one case, friends. If two equations are having both the roots common, then it has only one case. That case is the coefficients should always be proportional. That is, a1 by a2 is equals to b1 by b2 is equals to c1 by c2. So if two quadratic equations are having both the roots common, then in that case we say coefficients are proportional. If only one root is common, the approach is simple. We take, let alpha be the common root, let something be common root. We substitute alpha in equation 1 and equation 2, and we try to solve those two equations. That equation will give us the required one. No need of remembering any particular formula. Next, quadratic expression and its graph. Now let's say we have quadratic expression y is equals to ax square plus bx plus c. Ax square plus bx plus c is a quadratic polynomial. Now the graph of quadratic polynomial, if you see this, friends, This is a parabola. The graph of quadratic expression is a parabola. Now coming to parabola, it is always either upward parabola or downward parabola. Either upward parabola or downward parabola. Now when do we get downward parabola or upward parabola? That always depends on the value of the coefficient of x square. If the coefficient of x square is positive, then we get upward parabola. Then we get upward parabola. If the coefficient of x square is less than 0, then it is downward parabola. Now again, upward parabola can also be drawn in three cases, friends. One is completely lying above x-axis with respect to x-axis. We never include with respect to y-axis. Completely lying above x-axis or touching x-axis, just touching x-axis, or cutting the x-axis at two distinct points. Upward parabola can be drawn in three cases. One is lying completely above x-axis, or touching x-axis, or intersecting x-axis at two distinct points. So if the graph completely lies above x-axis, then that means the discriminant of this graph is, discriminant of this quadratic expression will be less than 0. Whereas if it touches x-axis, then it is equals to 0. And if it intersects x-axis at two distinct points, discriminant will be greater than 0. Even based on graph, we can say this. Okay. Now, whereas with respect to downward parabola, again even downward parabola can be drawn in three cases. Number one, intersecting x-axis at two distinct points. Number two, touching x-axis. Number three, neither completely lying below x-axis. So if it intersects x-axis at two distinct points, the discriminant of this quadratic expression will be greater than 0. Whereas if it touches x-axis at one distinct point, I mean touching the x-axis, discriminant will be equals to 0 and d will be less than 0 if it lies completely below x-axis. If it lies completely below x-axis, then the discriminant of this quadratic expression will be less than 0. Okay, next friends. Nature of the graph when d less than 0. Just now I have seen. So discriminant, that is if a quadratic expression ax square plus bx plus c has the discriminant less than 0, then the graph either lies completely above x-axis or completely lies below x-axis. Completely lies above x-axis or completely lies below x-axis. Let's say this is x-axis, y-axis, origin. Now, ax square plus bx plus c and discriminant is less than 0. Now see this friends, if a is greater than 0, then the graph lies completely above x-axis. If a is greater than 0, then the graph lies completely above x-axis. And if a is less than 0, then the graph completely lies below x-axis. This is the special case when discriminant is less than 0. Just now we have discussed in previous slide also. Why? Because no roots, no real roots, so it won't intersect x-axis at all. Okay, so the nature of graph when d less than 0 in two cases, whether a can be, if a is positive, the graph lies completely above x-axis. If a is negative, the graph lies completely below x-axis. And in this case, see friends, nature of the graph, for all x belongs to r, for all x belongs to r, for all x belongs to capital R, in this case, for all x belongs to capital R, in this case, the quadratic expression will always be greater than 0 only. So for any real value of x, the value of y will always be more than 0, greater than 0. And whereas in this case, for all x belongs to capital R, for each value of x, y will always be less than 0. Y is the expression ax square plus bx plus c. So any value you put in place of x, y will always be negative in this case. Any value for x belongs to capital R, y will always be greater than 0. Clear? And if you see this friends, if you see this, the range of this expression, you see, a quadratic expression will be has either only minimum or only maximum. In this case, you see, it has only minimum and it extends till infinity. It approaches infinity and it has only maximum. The least value, it starts from minus infinity. So, and in this case, the range of the quadratic expression, is the range of the quadratic expression. Now, we split it into two cases, friends. If a greater than 0, the graph is upward parabola. So, then that means y will be having only minimum. So, what is y minimum? Y minimum is equals to minus d by 4a. This point, friends, that is, this point is called as vertex, and the coordinates of this vertex is called as, this point is called as vertex, and the line which is passing through this vertex and parallel to y axis is called as axis of the parabola. Now this point is called as vertex. Coordinates of this vertex are minus b by 2a comma minus d by 4a. Minus b by 2a comma minus d by 4a. So whether a quadratic expression has minimum or maximum, it will be only at this point. Now, so if a greater than 0, the minimum value of the quadratic expression is minus d by 4a. Now range will be now, so range is closed minus d by 4a to infinity. Closed minus, because upward parabola, no, it has only minimum. So that the range is closed minus d by 4a to infinity. Suppose if a is less than 0, friends, then you get y maximum will be minus d by 4a, because graph will be like this. So in that case, range is minus infinity to, it starts from minimum will be minus infinity to maximum is closed minus d by 4a. So these are the range of quadratic expressions. Y is equals to ax square plus bx plus c. Clear? Next, how do you find the range of some algebraic expressions related to quadratic? In all the cases, very simple, friends. What we do, suppose if we have this expansion, let's say I'll take a general x square plus x plus 1 divided by 2x square plus 3x plus 1. We have anything, either quadratic by quadratic, any time we come across range of such expressions, quadratic by quadratic or 1 by quadratic or linear by quadratic or quadratic by linear. Approach is same. What is the approach? Now, simplify it and express it as a quadratic equation in only x. First, for that you cross multiply 2x square y plus 3xy plus y is equals to x square plus x plus 1. Now we have to express it as a quadratic equation in only x. So that means x square, if you take common, so you get 2y minus 1 plus x common 3y minus 1 plus y minus 1 is equals to 0. Friends, clearly you see this is a quadratic equation in x, which is of the form ax square plus bx plus c is equals to 0. Okay, now we know the range of this quadratic expression. They'll give you something that for all x belongs to capital R, if they say x belongs to capital R, for all x belongs to capital R, if x is a real number, that means the discriminant of this equation should always be greater than or equals to 0. So now what we do, we take b square minus 4ac, an expression b square minus 4ac always greater than or equals to 0. Just put b is equals to this a, c, and then we will be getting the range of the given expression, whether it is quadratic by quadratic or 1 by quadratic or linear by quadratic or quadratic by linear. The approach is, we'll simplify it, then we express it as a quadratic equation in only x. They'll give you that for all, find the range of the expression for all x belongs to capital R. In that case, if x is a real number, that means discriminant of the quadratic equation should always be greater than or equals to 0. So if d greater than or equals to 0 apply, then we'll be getting an expression in terms of y, friends. From there, if we can solve by using basic maths, we can get the inequality. We can solve the inequality. So that is what we get the range of the given expression. We will be getting the values of y. Y is nothing but the range of the given expression. Next, we have theory of equation. Now coming to theory of equation, this is nothing but generalizing all the equations at a face. See friends, for quadratic equation ax square plus bx plus c is equals to 0, ax square plus bx plus c is equals to 0. If roots are some alpha comma beta, then sum of the roots is alpha plus beta is minus b by a. Product of the roots is equals to c by a. Suppose if it is cubic equation, ax cube plus bx square plus cx plus d is equals to 0, where roots are alpha, beta, gamma, then same sum of the roots will be minus b by a. We start from a with alternate plus minus signs, plus minus plus minus. So alpha plus beta plus gamma will be minus b by a. Next, sum of the roots taken once, sum of the roots taken twice. Alpha beta plus beta gamma plus gamma alpha is again equals to c by a. Next, sum of the roots taken all at a time. Alpha into beta into gamma, that is nothing but product of the equation, product of the roots, which is equals to minus d by a. Now if we take a biquadratic equation, a into x power 4 plus b into x cube plus c into x square plus dx plus e is equals to 0. Even in this case friends, if alpha, beta, gamma, delta are the roots of this equation, then sigma alpha, sum of the roots taken one at a time, will be equals to minus b by a. Sum of the roots taken two at a time, sigma alpha beta, 2 like this, alpha beta, alpha gamma, alpha delta, beta gamma, beta delta, gamma delta, all this. Sigma alpha beta will be equals to c by a, and sum of the roots taken 3 at a times. So sigma alpha beta gamma is equals to minus c by a, and product of all of them, alpha beta gamma delta, or you can put sigma, you will get only 1, because when you take 4 roots at once you will get only 1. So that will be e by a. So this we can extend up to any number of any degree polynomial, clear ma? Apart from this, some results like we have factor theorem, remainder theorem. If alpha is the root of the equation f of x is equals to 0, then the polynomial f of x is exactly divisible by x minus alpha, and x minus alpha is called as a factor of f of x. Every equation of nth degree, n greater than or equals to n, exactly n roots. As I said it in the beginning, in case of roots and solutions, so every equation of degree n will be having n roots. So if the equation has more than n roots, then such equation is called as an identity. If the coefficients of the equation f of x is equals to 0 are all real, friends, are all real, and alpha plus I beta is one of the root, then for sure alpha minus I beta will be again one more root. The roots will occur in pair, friends. If alpha plus I beta is one root and all the coefficients are real, then alpha minus I beta will also be another root. An equation of odd degree will have odd number of real roots, and an equation of even degree will have even number of real roots. If the coefficients in the equation are all rational and one root is alpha plus root beta, the other root will be alpha minus root beta. Again, if all the coefficients are rational, then these irrational roots will also be occur in pairs, that is, irrational roots will be occurring in pair. If there be any two real numbers a and b such that f of a and f of b are of opposite signs, for such that f of x is equals to 0, must have odd number of real roots, friends, between a and b. Let's say there is a quadratic. Now at this case, let's say this is some f of a, somewhere we have taken f of a, this is a, and let's say this is b. Friends, if you see, what is f of a? Positive, f of b negative, f of a positive, f of b negative. So f of a and f of b are having opposite signs. Then for sure, how many roots do we have in between them? How many solutions? One exact solution we have. Number will be having one real root. Suppose if you take b here, if you take b here, now f of a positive, f of b negative, that means 1, 2, 3 real roots. So if f of a and f of b are any two values such that are having opposite signs, then for sure in between a and b we will be having odd number of real roots. Odd number of real roots, either 1, 3, 5, something in that way from this graph. So with that we are done with quadratic equations. Now we are entering into complex numbers, friends. So coming to complex numbers, general introduction. Natural numbers are subset of whole numbers. Whole numbers are subset of integers. Integers are subset of rational. Rational numbers are subset of real numbers. Now finally real numbers are subset of complex numbers. In general, friends, if you observe the number tree, complex numbers have been classified into real and imaginary. Now what are these imaginary numbers? Imaginary numbers means any number which are associated with the imaginary unit I. What is I? I is called as iota. We call this as iota, and this is equals to, we give the value of I as square root of -1. So any number which is associated with it, let's say some 2i, 3i, -i, all these numbers are called as imaginary numbers. Imaginary numbers. Now we know real numbers. Real numbers have again been classified into rational and irrational. So this we can go from rational numbers, integers, whole numbers, natural numbers. Now, what do you mean by complex number? Complex number means, in general, we denote complex. Set of complex numbers are denoted by C, friends. Set of complex numbers are denoted by C. But individual complex number, in general, we denote like ZB any complex number. So, let's say Z denotes a complex number. Now, how do we write a complex number? If x comma y are any two real numbers, if x comma y are any two real numbers, then any number which always of the form x plus iy is called as a complex number. That's it. If for every real x comma y real numbers, x plus iy is called as a complex number. So this x is called as real part of x and y is called as imaginary part of x. Real part, y imaginary part. Okay, we write it as real part of z is equals to y. Im, imaginary part of z, is equals to y. Not iy, only y. Okay, now if this real part is 0, friends, if this x is equals to 0, then z is said to be purely imaginary. Z equals to only iy, no, purely imaginary. If y is 0, that is imaginary part is 0, then z is purely real. Z is purely real. Next. So every complex number z can be written in the form of z is equals to x plus iy, where x comma y are any two real numbers and I is equals to root over -1. Just now we have seen this, friends. Now organed plane or complex plane, like we have Cartesian plane. Cartesian plane where x and y axis. In organed plane we will be having horizontal axis as real axis, vertical axis as imaginary axis. Okay, real axis, imaginary axis. So if I say z is equals to x plus iy be any complex number, then it also represents a point. It is represented as a point P of an ordered pair of real part comma imaginary part. It is represented on this organed plane. It is represented on this organed plane. Simple, friends, as like we have Cartesian plane. Okay, same origin we have x comma y means somewhere it is a x. This perpendicular distance will be x, y. So that is what we say. We say this perpendicular distance will be, this is x and this is y. So this point will be P of x comma y, or it is represented as a point given by a complex number z. So if we have each complex number can be represented as a point in this complex plane, So this plane is called as an organed plane. Horizontal one real axis, vertical one imaginary axis. Next, iota, integral powers of iota. If you see this, friends, I square is -1, I cube is -I, and I power 4 is +1. So integral powers of iota is for all I raised to multiples of 4, I power 4n is 1, I power 4n plus 1 is I power 4n into I power 1, which is equals to I power 4n plus 2 is I power 4n into I square minus 1, I power 4n plus 3 which is minus I, and I power 4n is 1. So for all integral powers of iota, we use these 4 things and we get the value of I. Now algebra of complex numbers. Adding two complex numbers is nothing but adding their real parts. Subtracting complex numbers is subtracting their corresponding real parts and imaginary parts. Multiplying is like multiplying two binomials, friends. Multiplying two binomials. But when you come across I into I, we write it as I square. I square value is minus 1. This is the only thing that we have. Now coming to division of complex number, we won't divide complex number with another complex number directly. Instead what we do, we multiply and divide with the conjugate of the denominator. What do you mean by conjugate of the denominator? So for any complex number x plus iy, x minus iy is called as its conjugate. X minus iy is its conjugate of this complex number. For every complex number x plus iy, conjugate is x minus iy, and for x minus iy, conjugate will be x plus iy, vice versa. So for conjugate x plus, for the conjugate of x minus iy is x plus iy, and for x plus iy, conjugate is x minus iy. Next, algebra of two complex numbers. Additive inverse, then doubly is additive inverse of z. That means if z1 plus z2 is equals to 0, then z2 is called as additive inverse of z1, vice versa. Z1 is called as additive inverse of z2. Multiplicative inverse. If z1 into z2 is equals to 1, then we call z2 as multiplicative inverse of z1 or z1 as multiplicative inverse of z2. Next, equality of two complex numbers. We say if two complex numbers are said to be equal if their corresponding real parts and imaginary parts should be equal. If they're both real parts and imaginary parts of two complex numbers are equal, then only we call it as equal complex numbers. Next, inequality of complex numbers are never talked. See friends, real numbers, if suppose A is a real number and B is real number, A greater than B, A less than B is some meaningful. 2 less than 3 or 2 greater than 3 is some meaningful. But if coming to complex numbers, Z1 is some complex number, Z2 is complex number, Z1 less than Z2, Z1 greater than Z2 is completely meaningless. So inequality of two complex numbers will never exist. It's completely an absurd, something which is not at all gives any meaning. Next, one more important friends, say root A into root B, till now we learn it as root AB because we didn't come across complex numbers. It is only when at least one of A comma B is non-negative. If both are negative, if both A and B are negative, then we write it as minus times root AB friends. If both A comma B are negative, if both A comma B are negative, then root A into root B is equals to minus root AB. Clear? Square root of a complex number. Simple friends. Root over A plus IB is equals to, first let's say let Z is equals to, let I write Z is equals to A plus IB. Now square root of this A plus IB is equals to plus or minus, what we do? We find mod Z, modulus of Z plus A by 2, okay? Mod Z plus A by 2. Now the sign here, it is plus, no? So here also it should be taken plus I times again square root of mod Z minus A by 2. So this is how we get the square root of a complex number. Square root of a complex number is root over, suppose we have find the square root of root 3 plus 4i. Then first we find modulus. Mod Z is root over 3 square plus 4 square, which is equals to 5. Then in that case plus or minus square root of mod Z, that is 5 plus 3 by 2. Here coefficient of I is plus only, so we put plus I times 5 minus 3 by 2. So that is 5 plus 3, 8 by 2 is 4, root 4 is 2 plus 5 minus 3 is 2, 2 by 2 1. So this is what we get, plus or minus 2 plus I. This is how we find square root of a complex number. Next, modulus of a complex number. So if z is x plus iy, then modulus of z is nothing but root over x square plus y square. Actually, the geometrical interpretation of complex number, modulus of the complex number is, friends, if this complex number z is x plus iy, it is represented as a point x comma y, correct? Now, if this P is the point which is represented as a point x comma y, then the distance from origin to P, or distance from origin to P, if we join P to the origin, the length of the line segment OP is called as its modulus, friends. This length is called as its modulus. So, modulus of every complex number will always be non-negative real number, will always be non-negative real number. This mod z, modulus of z will always be greater than or equals to 0. It can never be negative because it is clearly the length of the line segment. Distance will always be real, and that too non-negative. Conjugate of a complex number. So just now we have said, for a complex number z is equals to x plus iy, then x minus iy will be the corresponding conjugate. Now, how do we represent conjugate? See friends, suppose x comma y is this point, then z is equals to x plus iy, we have z is equals to x plus iy, z bar is denoted as its conjugate, and z bar is equals to x minus iy. That means it is represented as a point x comma minus y, x comma minus y. That means it is the image of this point. Conjugate is the image of the point in real axis, image of point P in real axis. So Q will be having coordinates x comma minus y. Clear? The image of P with respect to x axis, that is real axis, in the orthogonal plane is called as the conjugate of the given complex number. Is called as conjugate of the given complex number. Properties of some modulus and conjugate, friends. So modulus of z will always be greater than or equals to 0. Mod z is always equals to mod of z bar is always equals to mod of minus z is equal. All these are equal, because that means all of them are equidistant from origin, we say. Okay. Next, z into z bar. Whenever you multiply a complex number with its modulus, if suppose z is equals to x plus iy, z bar will be x minus iy. When we multiply a complex number with its conjugate z into z bar, this is always equals to x plus iy into x minus iy, and that is equals to again x square plus y square. So whenever we multiply a complex number with its modulus, we get square of the modulus. Mod of z1 into z2 is z1 into mod z1 into mod z2. Mod of z1 by z2 is mod z1 by, this is mod z1 by mod z2, mod z1 by mod z2. Separately we can write. Modulus of z power n is mod z whole power n. Next, conjugate of conjugate. Mod z bar whole bar will always be equals to z. When you add z plus z bar, when you add a complex number and its conjugate, you will be getting twice real part of z. Z minus z bar will be 2y times imaginary part of z. Conjugate of z1 plus z2 is conjugate of z1 plus conjugate of z2. Conjugate of z1 minus z2 is conjugate z1 minus conjugate z2. Next, conjugate of z1 into z2 will be conjugate of z1 into conjugate of z2. Conjugate of z1 by z2 whole is equals to z1 bar divided by z2 bar. Friends, all of them, all the properties are very important. These properties are properties of complex numbers, like we discussed in matrices and determinants, adjoint properties, inverse properties, transpose properties. In the same way, properties of these complex numbers like conjugate, argument, modulus, all these are very important. Majority of the problems can be done by using properties only. Next, geometrical interpretation of complex number. Now just now we have said, if z is equals to x plus iy be any complex number, it is represented as a point, x comma y in the orthogonal plane. It is represented as a point z x comma y in the orthogonal plane. Now z bar means, friends, what is z bar? z bar will be equals to x minus iy. So it is x comma minus y is a point, x comma minus y is a point which is image of z with respect to real axis. Okay. Next, lambda z means, see, lambda z means in generally some lambda times x plus iy. So if this lambda, there will be again two cases, friends. If lambda x plus I times lambda y, if lambda is greater than 1, then what happens? See, what happens actually? What happens mean? This lambda z will be lying on the same line segment, same line which is joining O and Z, but away from Z, above Z. So somewhere here we will be having lambda z, if lambda is greater than 1. If lambda is less than 1, then you will find lambda z here only, friends. Okay. Next, minus z, we have minus z means, now clearly minus z means minus x plus minus iy. So that is, it is represented as a point minus x comma minus y. Minus x comma minus y means exactly the image of z with respect to origin, this is minus z. Okay. Now the distance from origin to minus z and origin to z and origin to z bar, will these three be equal always? Next, 1 by z. 1 by z means, see, 1 by z means 1 by x plus iy. What we do? We multiply and divide with x minus iy. X minus iy means, friends, x minus iy divided by x square plus y square. Okay. So this is clearly something like 1 by x square plus y square into x minus iy. X minus iy is conjugate, and 1 by x square, this is like lambda into z bar. And for sure this lambda value is always less than 1, because 1 by something, no, less than 1. So 1 by z, the complex number 1 by z will be for sure somewhere lies in between origin and z bar only. 1 by z will always lie in between origin and z bar only. Clear? So this is how we represent the complex number z bar, lambda z, minus z and 1 by z etc. on the argand plane. Next, argument of a complex number. See, friends, simple again. If z is any complex number represented as some x, z is equals to x plus iy, then it represented as a point x comma y in the organd plane. Then the angle made by the line segment OZ with the positive direction of real axis. This angle is called as argument, friends. Argument. Okay. If OP makes an angle theta with real axis, one of the arguments of z, then one of the arguments of z is theta, then general values of argument of z are given by 2n pi plus theta. Because see, if this is theta, again this will be 2 pi plus theta, again one more 4 pi plus theta. So theta is the, if OP makes an angle theta with real axis, then this theta is called as argument, or we say amplitude. Now we have one more value called principal argument. So principal argument should always lie in between minus pi to pi. The argument theta is said to be principal argument if it lie in between minus pi and plus pi. It can be equals to pi, but not minus pi, is called as principal argument. Now how do we get principal argument? Very simple, friends. First, z is equals to x plus iy. Okay. Now irrespective of z, first we find alpha. Alpha is tan inverse of mod y by x. First find alpha. Okay. Alpha is equals to tan inverse of mod y by x. Now friends, depending on the quadrant in which z lies. If z lies in first quadrant, then theta argument is equals to alpha only. Argument is equals to alpha. If z lies in second quadrant, then argument is equals to pi minus alpha. Third quadrant, alpha minus pi. Fourth quadrant, minus alpha. So depending on the quadrant, if z belongs to quadrant 1, the principal argument, here theta is principal argument, so theta, principal argument theta is equals to alpha directly. If z belongs to q2, quadrant 2, then theta is equals to pi minus alpha. If z belongs to q3, then theta is equals to alpha minus pi. If z belongs to q4, then theta is equals to minus alpha. This is how we find principal argument of a given complex number. First we find alpha. What is alpha? Alpha is tan inverse of mod y by x. Then depending upon the value, depending upon the quadrant z lies, then we get the principal argument. First quadrant alpha, second pi minus alpha, third alpha minus pi, fourth is minus alpha. Next, the least positive argument is always 0 less than theta less than or equals to 2 pi is always called as least positive argument. Now representing a complex number, there are three different methods, friends. We have vectorial form also, but not important. Cartesian or algebraic form. Till now whatever the form that we are discussing is called as Cartesian or algebraic form, trigonometric or polar form, exponential or we say Euler form. Exponential or we say Euler form. Now first, Cartesian form. If z is equals to x plus iy be any complex number, friends. Z is equals to x plus iy be any complex number. Next, we find r to express it in trigonometric or polar form. R is the modulus. Modulus of the complex number is root over x square plus y square. And principal argument theta. Principal argument. Let theta be the principal argument. Let theta be the principal argument. If theta is the principal argument and r is the modulus of z, then the same z is equals to r into cos theta plus I sin theta. We express it as, this form is called as trigonometric or polar form, friends. Okay, r of cos theta plus I sin theta. We also write it as r cis theta. Cos theta plus I sin theta, we can just write it as cis theta, the short form of this. Next, coming to exponential form. Once you know r and theta in exponential form or in Euler's form, z is equals to r into this cos theta plus I sin theta, we can write it as e power I theta. E power I theta. So this is polar form and this is Euler's form. Polar form, next Euler form. So z is equals to r of cos theta plus sin theta, I sin theta, or we say z is equals to cis theta, where r is modulus of z and theta is amplitude of z. Exponential form is r into e power I theta, r is modulus, theta is amplitude. Properties of argument, friends, these are very important. Argument of z1 into z2 is argument z1 plus argument z2 plus 2k pi. 2k pi is to adjust the value in terms of principal argument. Okay. Next, argument of z1 by z2 is argument of z1 minus argument of z2. Argument of z power n is n into argument of z and argument of z power is minus argument of z. This 2k pi is added only to adjust the value, because see, if I say argument of z is some pi by 3. Argument of z power 4, if I say, argument of z power 4 is 4 times argument of z. 4 into pi by 3, 4 pi by 3. But principal argument should always be less than pi, no? Should always be less than or equals to pi, no? For that, what we do? We subtract 2 pi. So this 2k pi, put k equals to minus 1, then we get minus 2 pi can be subtracted. So by subtracting 2 pi from 4 pi by 3, my value will be adjusted in between minus pi and plus pi. Okay? These are very important, friends. All the properties of argument. Next, argument of z1 z minus z2 divided by z minus z1 is equals to theta. Then locus of z is a circular arc. If theta is acute, then it is major arc. Theta is obtuse, then it is minor arc. Next vectorial representation is something, see friends, PQ, the length of the line segment is mod of Z2 minus Z1. PQ is equals to mod of Z2 minus Z1 or Z1 minus Z2, and argument of Z2 minus Z1 is theta. Argument means friends, if we extend this, so this is theta. So argument of Z2 minus Z1 is some theta. Now triangle inequality, which are very important friends, kindly make a note of this. Modulus of mod Z1 minus Z2 is always less than or equals to mod Z1 plus Z2 less than or equals to mod Z1 plus mod Z2. In the same way, mod of Z1 minus Z2 also. Next, correlation between complex numbers and coordinate geometry. Same friends, just now we have seen. Now see, argument of, let's say argument of Z1 is some theta 1. Argument of Z2 is equals to some theta 2. Okay. Now, if this is the angle, suppose if this is the angle theta, now this whole is theta 2 and this is theta 1, no? So, for sure, theta is equals to theta 2 minus theta 1. That means theta is equals to what is argument of Z2 minus argument of Z1. We already know the properties of argument. Argument of Z2 minus Z1 that is argument of Z2 by Z1. Argument of Z2 by Z1. So if theta is the angle between Z1 and Z2, then that is equals to theta will be equals to argument of Z2 by Z1 with respect to origin. If we take with respect to some Z3 friends, then theta will be equals to argument of Z2 minus Z3, argument of Z2 minus Z3 divided by Z1 minus Z3. Argument of Z2 minus Z3 divided by Z1 minus Z3 will be giving this theta friends. Okay, or we say in rotation of complex numbers also we will discuss the same. This Z1 with respect to Z3 is rotated by an angle theta, and we have got Z2 then this theta is said to be angle of rotation, and that theta will be equals to argument of Z2 minus Z3 divided by Z1 minus Z3, and that is what? Coming to rotation of complex numbers friends, if Z is any complex number and mod of Z is mod of that line segment is some P, then if this Z of P of Z1 is rotated through an angle theta in anti-clockwise direction, let's say to get Z2, then this Z2 will be equals to Z1 into e power I theta, Instead of origin, if we have a point Z0 friends, then Z2 is equals to, that is Z2 minus Z0, same story again, Z2 minus Z0 is equals to Z1 minus Z0 into angle of rotation, e power I theta. What is theta again? Just now we know theta is equals to argument of Z2 minus Z0 divided by Z1 minus Z0 again. Okay, so this is what the rotation formula. And again, de Moivre's theorem. So most cases we use this friends. If Z is equals to cos theta plus I sin theta whole power n, by using mathematical induction we can prove this. Then Z power n is cos n theta plus I sin n theta. If n belongs to I, this is the only value. Suppose if n belongs to a rational number, then this is one among the values of Z. We will be having many values. One among them is cos n theta plus I sin n theta. Okay. Next, cube roots of unity. Let's say Z be any complex number which is equals to cube root means 1 power 1 by 3 friends. Okay. Now cubing on both sides, we get Z cube is equals to 1. Z cube is equals to 1. Z cube is equals to 1. See this friends, instead of doing like this, okay, z cube minus 1 is equals to 0, we can factorize z minus 1 into z square plus z plus 1 is equals to 0. So either z equals to 1, or if we find by using quadratic formula, minus 1 plus or minus under root b square minus 4ac. 1 minus 4 is minus 3 divided by 2, which is minus 1 plus or minus I root 3 by 2. Now these values 1 comma minus 1 plus I root 3 by 2 and minus 1 minus I root 3 by 2, these three are the roots of this equation, friends. These three are the roots of cube root of unity. So that means these three are called as cube roots of unity. These three are called as cube roots of unity. In general, we denote them as omega as minus 1 plus I root 3 by 2. Now if we square this, friends, we get this omega square, or we can take this also omega. See, the advantage with this is if you square this you get this, and if you square this you get this. So in general, cube roots of unity are 1 omega square, 1 omega square. Now the properties of cube roots of unity is sum of the cube roots of unity is always equals to 0. Sir, how? See, friends, z cube minus 1, it's like x cube minus 1 is equals to 0, no? It's a polynomial equation. If let's say alpha, beta, gamma are the three roots of this cubic equation, what is sum of the roots? Minus b by a, no? B is the coefficient of x square, no coefficient of x square, that's it. Next, product of the roots, that is 1 into omega square, that is omega cube, is equals to omega cube, product of the roots in this case is minus d by a. So minus of minus 1 by 1, which is, so product of the roots omega cube is equals to 1, sum of the roots is 1 plus omega square is equals to 0. Next, we can go with like integral powers, like we have integral powers of iota, integral powers of omega, cube roots of unity also. Omega power 3 1, omega power 3n 1, omega power 3n plus 1 is omega power 3n plus 2 is omega square. So if omega is one among the non-real cube roots of unity, then for sure 1 plus omega square is equals to 0. For any power r also, if r is a multiple of 3 lambda, r is a multiple of 3, then this will be equals to 3. If r is not multiple of 3, 1 plus omega power r plus omega power 2r will always be equals to zr. The three cube roots of unity will always, when they are plotted on the argand plane, they represent an equilateral triangle, friends. If you are plotting, see, what are the roots? 1 means 1 comma 0. Next, omega means somewhere it here, omega square. So if you plot all this represents a equilateral triangle. ABC will be forming an equilateral triangle, and center of this, suppose if we draw circumcircle passing through all the three vertices, the center of this circle will be origin only. Next, ABC belongs to R, omega is the cube roots of unity. X square plus x plus 1 can be written as x minus omega into x minus omega square, because the roots of this are omega and omega square only, no? A cube minus b cube, we can write it as a minus b into a minus omega b into a minus omega square b, all these three, friends. Next, nth roots of unity. In the same way, nth roots of unity, let's say z is equals to 1 power 1 by n, okay? Now z is equals to, this 1 we can write it as, cos 2k pi plus I sin 2k pi, k be any integer, whole power 1 by n. Now z is equals to cos 2k pi by n plus I sin 2k pi by n. Now friends, when we take k is equals to 0, 1, 2 and so on till n minus 1, and so on till n minus 1, you will be getting nth roots of unity. Those nth roots of unity are cos 2k pi by n plus I sin 2k pi by n. So if 1, alpha 1, alpha 2 and so on, alpha n minus 1 are the nth roots of unity, then they will always be in GP with common ratio, this one, friends, the common ratio e raised to I power 2 pi by n or cos 2 pi by n plus I sin 2 pi by n and lie on standard unit circle on the organoid plane. The nth roots of unity represent the vertices of an n-sided regular polygon. N-sided regular polygon. Next, some important relations with respect to cube nth roots of unity like we have in cube roots of unity. Go through it, friends. Go through it. Next, 1, alpha 1, alpha 2, alpha 3 are then nth roots of unity. Then z power n minus 1 can be written as, because if they are roots, then we can write it as in factor form. Next, correlation between complex number and coordinate geometry. Z1 and Z2 are any two complex numbers. Then Z1 minus Z2 or Z2 minus Z1 represents this complex number line segment. Mod of this will be the distance from Z1 to Z2, that is length of the line segment joining Z1 and Z2. Next, section formula as usual, like if there is a complex number Z dividing Z1 and Z2 in the ratio m is to n, then Z is given as mZ2 plus nZ1 divided by m plus n. Centroid Z1 plus Z2 plus Z3 by 3, when Z1, Z2, Z3 are the three vertices of a triangle, then in center is AZ1 plus BZ2. All the formulae that we have in coordinate geometry, we can just correlate to complex numbers. Orthocenter, circumcenter. So with that, friends, we are done with complex numbers. Now we are going to start statistics. Okay. In statistics, we know how to find central tendency measures. We have three central tendency measures called mean, median and mode. We have seen this until grade 10 also. We know how to find mean, how to find median and mode for different frequency distributions. So finding mean is a central tendency. Mean is nothing but, in simple words, we call it as average, friends. Average. So mean is generally, in general, we denote mean as x bar. Mean as x bar, and x bar is equals to sum of observations divided by number of observations. This is for raw data. This is for raw data, and this is for we can say discrete frequency distribution. Discrete frequency or even continuous frequency also we can do in the same way. So for raw data, x bar is equals to, we take the sum of all the observations divided by total number of observations, we get mean. For discrete frequency or continuous, sigma fi xi divided by sigma fi. So for class wise data, what we do, first we find class marks. Okay, we find continuous frequency distribution. For class intervals, what we do, first we find xi's, then that xi is our fi xi. Okay, now we need to study the dependence of x bar on the change of. This is what something important. Now friends, if xi is observation, if each observation is increased by a constant k, if each observation is increased by a constant k or decreased, anything is fine, then how the mean is going to change? Mean will also be added by the same constant k. Clear? So if each observation is added by a constant k, then mean will also be added by constant k. In the same way, if each observation is multiplied by k, then the new mean also will be multiplied by k. So this is the change of, with respect to observation, how the mean is going to be changed. Next, median. Median is nothing but the middlemost observation of the given data, friends. Middlemost. First, what we do, we have to arrange the data in either ascending or descending order. Next, if n is odd, then median is value of half of n plus 1 by 2th observation. If it is even, then it is the average of n by 2 and n by 2 plus 1th observation. In general, we denote median with capital M. Median with capital M. Now, median of discrete series, like for raw data and all, what we do, for raw data we have seen already. Now for them, arrange the values of the variate in ascending or descending order. We will prepare a cumulative frequency distribution. Now median is the observation whose cumulative frequency is equal to or just greater than n by 2, where n is the sum of the frequencies. Now for continuous frequency distribution, what we do, friends, we will prepare a cumulative frequency distribution table and we will write a cumulative frequency CF. Now cumulative frequency, if the total frequency is n, just greater than n by 2 will be median class. The median class, which is the class which is having cumulative frequency just greater than n by 2 will be median class. Now once we get median class, then median is equals to L plus n by 2 minus Cf by f into h, where L is the lower limit of the median class, n by 2 is half of the frequency, half of the total frequency, minus Cf means cumulative frequency of the class preceding the medial class, f means frequency of the median class, h is class size. We have all, friends, we have discussed all these in grade 10 only. Okay. Next, mode means the observation which has greatest frequency, or the most occurred observation is called as mode. So in case of individual series, the mode is the value which occurs more frequently. In case of the mode is the value, that observation which occurs with greatest frequency. In case of discrete frequency, quite often mode can be determined just by inspection, by looking to that value around which the items are most heavily concentrated for discrete frequency. Whereas for continuous frequency, we have a formula, friends. So mode is equals to L plus f1 minus f0 by 2f1 minus f0 minus f2 into h. L is the frequency of model class. F1 is the frequency of model class, F0 is the frequency of class preceding the model class, F2 is frequency of the class succeeding the model class. So if you know all of them, then just by substituting we have got. So we know how to find these three values in grade 10 only, how to find mean, median, mode for even continuous frequency distribution. And we know empirical relationship. Empirical relation is mode is always equals to 3 median minus 2 mean. Mode is, this formula is called as empirical formula, or the empirical relationship between these three. Mode is always equals to 3 median minus 2 mean. So if 2 are known, we can get the third one by using this relation. Now this is what important, friends. Now coming to these, in this grade we are going to discuss measures of dispersion. So first, in measures of dispersion, we will be finding mean deviations about mean, median and any given number. Next, standard deviation, variance, range and coefficient of variation. First, what do you mean by mean deviation? First, we will understand what is deviation. Okay, what is deviation? Friends, we have observations x, let's say x1, x2, x3, x4, x5 are some 5 observations. Okay, deviations means with respect to a particular value, suppose let's say there is some value, some k. Deviations means the absolute difference of each observation from this k, that is x1 minus k modulus, x2 minus k modulus, x3 minus k modulus, x4 minus k modulus, x5 minus k modulus. These 5 are called as deviations, friends. Deviations. Okay. Now if we are going to find the mean of these deviations, we call it as mean deviation. Okay. If we treat these 5 observations as new observations and we find mean, then we call such mean as mean deviation. Now mean deviation about mean or median or any given number, that all depends on the value of k. So if we take this k as mean, then we get mean deviation about mean. Okay. If this k as median, then we get mean deviation about median. Any given number like this k. Okay. So to find mean deviation about mean, first what to do? First we have to find the mean of the given series. First find mean, then deviations. How do we get deviations? Like this, x1 minus x bar, x2 minus x bar, x3 minus x bar, x4 minus x bar. Absolute deviations we say. Okay. Now, once you find deviations, find the mean of those deviations. That's it. That is what mean deviation about mean or median or any given number. So in place of that number, if we can replace in place of k, if we can able to replace mean, then we get mean deviation about mean. In place of k, if we replace median, mean deviation about median we get. If in place of k any number, then mean deviation about any number. Okay, first we'll see mean deviation about any number a. So that is what, friends. First we find absolute deviations, then sigma means sum of all those absolute deviations divided by n. We get mean deviation. So mean deviation about any number is, for raw data, generally we say sigma xi minus a divided by sigma fi, that is n. So for continuous frequency distribution or discrete frequency, generally we have sigma fi xi by sigma fi, no, fi into, in place of observations we take deviations ma. So sigma fi into xi minus a divided by n. So for mean deviation about mean, we take x bar in place of a. For mean deviation about median, we take capital M in place of a. So that's it. That's how we get mean deviations about median and mean, or even about number. Then mean deviation will always be minimum, friends. If they ask find the minimum mean deviation, then we get minimum mean deviation only if we take about median. So deviation, mean deviation will be minimum only if we take about median. That means in place of a, if we put capital M, if we put median, then only the value will be minimum. Next, so standard deviation, or we say variance. First we find variance, then we go with the standard deviation. Now variance means, friends, variance is denoted as sigma square, okay? And the relationship between variance and standard deviation is, variance is equals to, or we say standard deviation is equals to square root of variance. Square root of variance. So variance is denoted as sigma square. Variance is denoted as sigma square. Then standard deviation will be sigma. That's it. Okay. Variance sigma square. Standard deviation sigma. Now what is variance? See, we have understood mean deviation. Okay. Now variance is, now we get deviations. No, friends, we get deviations. Let's say x1, x2, x3, x4, x5 are 5 observations. Okay. About mean. Okay. Just find mean. Now we are finding mean. Now we find deviations about mean, friends. Deviations about mean. Xi minus x bar, x1 minus x bar, x2 minus x bar, x3 minus x bar, x4 minus x bar, x5 minus x bar. What we found? We found deviations of the observations with respect to mean. If we square each deviation, x1 minus x bar whole square, x2 minus x bar whole square, x3 minus x bar whole square, x4 minus x bar whole square, x5 minus x bar whole square. We have got squares of the deviations. So the mean of squares of the deviations, the mean of the squares of the deviations, the mean of the squares of the deviations is called as variance. Variance is nothing but the mean of squares of the deviations, that is sigma xi minus x bar whole square divided by sigma fi, or we say n. This is what we say variance. Sum of the mean of the squares of the deviations. So this we can also write it as, friends, sigma xi square divided by n minus sigma x bar square, or x bar square is minus x bar square. Okay, sigma xi square divided by n minus x bar square is nothing but variance. Now square root of variance is our standard deviation, friends. Square root of variance is standard deviation. So variance is simply sigma square. Range is always nothing, highest observation minus least observation is called as range of the data. Next, coefficient of variation. Coefficient of variation is standard deviation divided by mean into 100. We get CV. Coefficient percentage. Coefficient of variance is standard deviation by mean. In case of percent, we need into 100. So CV is independent of units, friends, because see, standard deviation is sigma, mean, all are related to observations only. Observation divided by observation, you won't get anything. So CV is independent of units. So with that, friends, we are done with quadratic equations, complex numbers and statistics. Okay. So with this, we are done with our JEE Mantra series. Okay. Prepare well for the coming exam. All the very best, my dear friends. Good luck. Take care.